Thanks, Sean. Morning, guys. You got my screen there, all sorted. You heard we've only got
All's good.
the Taskmaster gave us 20 minutes, so let's get dipping into this. This morning's topic, questions and answers. These are questions that the guys have been sending through to me or to that have cropped up in the process or while we were busy dealing with other matters. Some of these came up, so let's dip straight into them. One of the issues we're having at the moment, may we as qualified plumbers install instantaneous gas geysers? And the answer is quite frankly no. Unless that unit that is being installed is tested or was tested to 18024, which is the standard for gas geysers, not the actual safety, gas safety, this LPGA, this. There is a standard for gas geysers. So even the storage one fall under the same. Let me just get my hand out. Just sorry, guys. There we go. Even the storage ones fall under the same standard. And then the second point is that if the size of the unit, instantaneous or storage, and the net power rating is calculated as per 10252.1, we'll have a look at that. And then the installation complies with parts of 10252.1, 10254 geysers, 10106 solar, and 1352, which all require balance pressure. You can't just now, because you're not using a normal electric storage geyser, forget about balance pressure. And the installation of the gas part is done by an LPGA accredited installer. I know some of our brethren or some of our colleagues have got gas or are registered as gas installers. Leave the gas up to them. We don't want any unnecessary hassles. The thing about instantaneous geysers, the standard says in most cases the instantaneous water heating process is triggered by a differential pressure switch, remember that, and an orifice restrictor. This causes higher downstream hot water flow pressure drops than with storage water heaters. Therefore, pipe design, pipe sizing, and simultaneous use of terminal fittings shall be carefully considered and calculated to ensure sufficient hot water and balanced hot and cold water pressure at terminal fittings. Let's have a quick squiz at this little detail here. What we do have here is cold water coming in, and you've got an orifice, and you've got a solenoid type valve that picks up that there's flow, and the flow then activates the flames that heat up the whole heat exchange section. So you've got cold water coming in and it heats up and it goes through the valve and back to the other side. But bearing in mind, you see a hot water pipe. So what happens is Mr. Plumber needs cold water on the same side. The difference is that the cold water feed goes straight to that fitting and the hot water gets restricted through these various valves and solenoids and what have you inside that unit. The biggest issue then becomes, not only is it not balanced, but the moment there's a little bit of back pressure from the cold water or even just halting the flow on that hot water, flow sensor picks up that there's no hot water moving through the system. So what happens is, poof, flames go out and you end up having to jump left and right to get these things sorted or to have start from scratch with your settings. We've already spoken about the components of the system shall be installed that the hot and cold water delivery pressure to water mixing components is balanced, and the residual, in other words, the balance of what is there, dynamic pressure at the fittings shall not vary by more than 20%. This requires that the layout and the pipe sizes be correctly calculated. So this formula you'll find in 10252 part 1. What it basically says is you take the literage on the hot water times the temperature of the hot water plus the literage of the cold water and the temperature of the cold water, and you divide it by the volume of the water, hot and cold together, and that'll give you the temperature mixed. So in this case, a shower that was set at 10 liters per minute at 38, you'll find that 5 liters at 60 degrees and 5 liters at 16 degrees divided by the volume of the two fives, you get to the 38, which is still, it's a nice hot shower, but it's not an issue. The problem then comes is when you drop the 20%. So you do the same formula, the literage for the hot times the liter or plus the literage for the cold, and you combine the two down the bottom, and you find that if we drop 20% out of the 5 liters of cold water, your math changes and it jumps from 38 to 40.4 degrees, which is still not vicious, but if you look at the following table, problem that you do have with unbalanced pressure is you're looking at temperature shocks and difficult hot and cold mix. So while you're struggling to get this reduced flow hot water and cold water to mix, there's water wastage, and the water just runs and runs until you get a setting. And once you're happy, the guy next to you in the shower cubicle next to you, when you're at a sports field or something, or someone in the kitchen opens a setting and there's everything gone down the tubes. Just to have a look at the temperatures, we're looking at 40.4. Like I said, it'll make you jump or it'll make you move, but it's not that bad. At 41, you're in a warm bath. When it goes up to 42, becomes very hot to the skin. And at 49, you're looking at first degree burns. That's not scalding, that's first degree burns in 4 minutes. So you can imagine if an elderly person or a youngster in a shower and something like that happens, for them to move around and then try and get out of the water. 52 degrees, first degree burns in 15 seconds. At 60, you've got 1 to 1.5 seconds to react before you have your first degree burns. So once you get, you see this, these are small increments, but there's three degrees difference between that. So it does make a huge difference. Just something to bear in mind when you're dealing with gas geysers. Then a plan submitted to the local authority gets approved. May a plumber deviate from such an approved plan? Once again, the answer, very bold, no. These approved plans are legal documents. You'll find that if you ever look at them on site, the owner would have signed on them, the architect would have signed on them, and the local authority would have applied a stamp to them to say that they are approved. But if you see a problem in complying, please consult the plumbing and drainage inspector, or the building inspector for that area. Or like we did in the rational design thing, you need to inform your client that although these are approved, you'll find that some of the local authorities actually have it in their bylaws that despite the fact that they've given you an approved plan, if there's a mistake on the plan, the responsibility is still with the plumber to make sure that he fixes or he does it properly. And then otherwise, they will still issue your client with a notice to say that the plumbing work doesn't comply. I think that the first one I picked up on that was Chwane. So the guys up there, have a look at your bylaws, but it's definitely an issue. We've done this before. Initial consideration for design by the designer, not Mr. Plumber, not Mr. Site Foreman, not even the owner. Once these documents have been submitted, the information as necessary should be obtained from the owner of the premises or from the water supply authority. We're looking at a site plan, everything the plumber needs, the function in the premises, the drawing of the building showing the points where the water is required, the type of fixtures and apparatus that you're putting into the building, a schedule of the sanitary fixtures, that's more for the bigger buildings, the design population that would all have been taken into account, quantity of water, the nature of the subsoil, the quality of the water obtainable from the main, the static and where possible the residual pressure, and water quantities and flow rates obtainable from the water supply main for the various types of demand. In other words, you can't put up a building that needs 75 millimeter supply to satisfy the requirements of that building, and you have a 50 millimeter main on the verge or where the municipal main may be. If applicable, a schedule of acceptable pipes and fittings, requirements for the drawings and other information that has to be submitted for obtaining approval, and any special precautions to be taken for the crossing of other services, details of existing connections and services, the location of the point of connection to the main, details of the metering in the owners. If the owner has to connect to the water installation, then obviously the size and the material and all the rest of that for water meterage. So basically, when you walk onto site and you're going to do this house or office or block of flats or sectional title development, all of these points should have been dealt with before you get to site. If you do, however, get a copy of a plan, please don't be the one that works according to plan and gets nailed at the end. We did that in a previous tech talk. You can go back to one of those tech resolutions. If there's an issue, you inform the owner or the designer or the In some cases, when it comes to, Sean mentioned backflow earlier, you can even advise the council that there's an issue with this installation. Put it in writing to someone, send an email, have it minuted. Make sure that you cover yourself by saying, despite the fact that someone approved this plan, we can't keep going in the direction that we are because this is wrong or that is wrong. And then by the time the job needs to get signed off, some cases we do not always have BCO in all the areas that we need these buildings signed off, and then you find out that when the IOPSA compliance auditor comes along, there's a huge negotiation and argument around, sorry, we don't argue anymore, we discuss that there are non-compliances on the site, so it's something that we need to pay attention to. Then the last one for this morning, question, can a job be failed because of pipework being undersized? Guys, we're all working on cost, or we're all looking at the cost of projects. But when you do get to a double-story house and the whole house is supplied in 15 millimeter pipe, then it becomes a hassle. There's a couple of municipalities or metros that have actually covered themselves in that regard. So when you look at the requirements in the bylaws, I've only taken 2 examples just for the time's sake. The pipe diameters in a water installation must be sufficient to provide a volume of water required for the proper functioning of any part or parts of a water installation without exceeding the rate of flow specified in 7212, which we'll have a look at just now, of 10252 part 1. The diameter of that pipe must be maintained up to the point or points where the volume is required. I remember 32 years ago when I was an apprentice, one of the first things I was taught when you did the master bets, or the holder bets, those were the only things you were allowed to do, and you make sure that you take the 22 mil one up to the second last point, and that would be a 3/4 half T, and then your journeyman would come along and fit the pipes and that, but please make sure that the diameter goes up to that second last point before you stop. Sizes of pipe, here you can see it, Tequini, they've got you in the same requirements. Pipes will be sufficient, and the size will be of that pipe be maintained up to the point or point where that quantity is required. Normally the second last point, and then you go half or whatever you need from there, or 3/4 half, whatever you need. The point is that you maintain that pipe sizing. So the requirement is in that bylaw, but then both of them refer to, this one refers to an extract from 10252 part 1. The previous one actually refers to 10252 part 1 directly. We're looking at 10254, your 20% is still required because you need the balance pressure. So this requires that the layout and the pipe sizes shall be correctly calculated in terms of 10252 part 1. So there was a reference twice made to 10252 part 1. So let's have a look at that. Very important, where a water supply installation is to be extended, the existing system shall be examined to ensure that it's suitable for extension. In other words, if Mrs. Jones has got a nice house on a property and she wants to extend by adding 2 bathrooms or 2 rooms with en-suites, and she's got a 15 millimeter supply, then this would be very applicable. You first assess, after which the entire design shall be reassessed and modified by the designer as appropriate. So by the time you get that document and there's no mention of pipe size, you get some local authorities like ours that are very tight on that. They actually want the pipe sizing on the building plans. So you indicate up front what you're going to be doing with this lot. And then the changes or the upgrades are indicated so that when you get to site, you would have quoted against 5 or 6 other guys, and everybody would have been working towards having that same pipe size on the actual building. As far as the hot water is concerned, the energy efficiency of those building SANS 204 and 10400XA shall be considered. So you need to make sure that if there's any return mains or there's a ring main or whatever installation as far as pipe sizing is concerned, we stick to all of the requirements in the standard. Then we jump from the design to the actual installation, and you'll see that when it comes to design pressures and flows, unless otherwise required. In other words, if you need more, or it's like an industrial building, or it's a factory that runs on processes and applications, The design static pressure at any terminal fitting other than a fire hose reel or a hydrant shall not exceed 600 kPa. We know that, and that was the straightforward bit, because when you buy your material, you start off first fitting pressure control or pressure reducing valve, and you install that depending on your solar system or the rest of your requirements. Some of those might be 400 kPa. But then the bigger thing comes in and it says, unless otherwise required, for example, by the fire guys, the velocity of flow in a pipe shall not exceed 3 meters per second for buried pipelines and for pipelines installed above ground where noise is not a factor. In other words, if it's in the middle of an engineering factory and there are machines and presses and drills and whatever you're running, then obviously the bit of noise made by the noise made by the pipeline is not going to affect anyone. Most of the local authority bylaws require that between 1.5 meters per second to 2.5 meters per second, depending on the installation and the noise levels allowed. Simple example, you'll find that you get some of the ball valves that when they get to that last 10 seconds or so before they close down, they end up screaming like tires on a piece of road. That would be exceeding the speed of 1.5. So obviously it's either there's a valve semi-closed or that opening. For the guys that did the 10252 part 1 course, you would have seen that it's better to get a bigger opening at a lower pressure to get that water in there and to try and squeeze a higher pressure through that little orifice on that ball valve. So the requirements are all over the standards. The last thing I'd like to touch on, if you were to look at the back of 10252 part 1 annexure I, you'll find that in this case the material is 460/0 copper, so it could be any of those. There are tables for plastic, copper, UPVC, the whole lot. 2.5 meters a second, we'll draw the line at that red line is the actual 2.5 meters per second, so that would block just about anything above that from an installation. So when you look at this table, it looks very complicated, but it's not. These little rectangles here indicate the pipe sizes starting from 15 mil and they go right through to 105 mil copper. When you're looking at the velocities over here, we know that it's 2.5 meters above ground and 3 meters underground. So anything here would be acceptable, but nothing above the red line. Then you look at the right-hand column and it actually indicates the flow rate. In other words, what you require inside your building in liters per minute. And the bottom one, very interesting little section of the graph. You start from 0.02 kPa and the top end of the scale is 9 kPa pressure loss per meter. So if you're doing 11 meter piece of pipe times 9 kPa will give you 99, which is just about 100 kPa. So when you're squeezing in the top end here, you're losing friction and you're losing pressure in that pipe size for absolutely no reason at all. Simple example, average house you'll find runs between 40 and 50 liters per minute. That's a reasonably average house. So if you go across here and you get to the 2.5 meters per second, you'll see, oh, there we go, 22 millimeter pipe. That'll suffice up to 50 liters a minute. Once you start needing 100, you'll see 100 and the 22 mil, they don't even get together on the same graph. So if you're putting up a building with 100 liters per minute requirement for that, you'll find that they don't even meet. Same thing happens with a 15 millimeters at 2.5. You can work your way back anything around 20 plus, just over 20, 25, you're in trouble, because then it means that you shortchanging the flow on that system there. So it is available at the back of 10252 part 1. Like I said, various materials, all the rest of that. So if there's any hassles, have a look at that or speak to your local, most of the local suppliers or the merchants and the professionals actually have this and they'll do it for you on a spreadsheet. But have a look at this pipe sizing thing. It is an issue. I know it's a money saving thing and the client's this and client's that, but you know what? The client's not going to phone the architect or the builder because there's no water coming out of his shower, or he's showering on the first floor and someone opened in the kitchen downstairs and the water disappeared. Mr. Plumber's in trouble. So have a look at that. It is something that we need to consider when we work on these systems. So I've kept to my 20 minutes, Mr. Frey. Have we got any questions?
You in fact have a couple of questions here, so I'm going to get right into them. The first
Okay.
one reads, if I tie into an unbalanced pipe, meaning there is no HWC, just a gas geyser, it would be the pressure of the municipal line of any given time. But if there is a HWC and unbalanced, can I put a PRV to balance the pressure at the gas geyser?
I'm going to say no, for the simple reason that you would be taking care of the actual pressure, but you're not looking at the volume. The volume would still be substantially less than what your incoming supply is going to be. So you might have a 3/4 pipe at 400 kPa, and you have a 3, 4, 5 millimeter diameter hole inside the unit at the same pressure. So there will always be an imbalance as far as volume and pressure is concerned. I know some of the gas manufacturers have now come out and said that they've got, what do they call them, zero start, and they've got various computer little fittings and what have you that they're working on. So speak to your manufacturer, but as far as the standard's concerned, you need to have the same, you need to have balanced pressure. So if you have a 22 millimeter pipe opposing a 3 or 4 millimeter pipe running through the flames there trying to heat that instantaneous geyser, that is a definite mismatch.
Right, then the next one here reads, can we use a composite / PEX water piping for geyser overflows? Certain municipalities are allowing this to be used throughout the plumbing installation.
If it's an approved type, yes. The main thing is you need to have a look at your local authority bylaws. In our one, you may use the composite pipe. The main issue is that you still need to have them obviously fitted properly. The material is approved, and then secondly, the most important thing is, as far as your local authority is concerned, in our case, you need 2 meters of copper pipe either side of the cylinder. So you're looking at the hot water cylinder, 2 meters on the cold water side, 2 meters on the hot water side. Then you can change over with a fitting on both of those lines, but you need to have the 2 meters copper. I know some of them go down to like a half a meter. There are various requirements, but the main thing is you need to check with your local authority. Some of them allow that, some of them not at all. The main thing is that you need to check what they need or they require. In our case, our electrical department put that requirement up because of the bonding and all the rest of that. So they want 2 meters either side of the cylinder.
Right. The next question reads, I separate the hot water line outcoming with an isolation valve or switch off the HWC so to use the gas geyser. Can I do that?
I'm not 100% sure about that arrangement. I hear what you're saying about separating the hot water line. The big issue is that from my perspective, we've had 4 consultants trying to work on municipal buildings as like like caravan parks and the chalets and that. So these buildings, and between the 4 of those consultants, they have not been able to come up with a rational design. I say rational design, we throw that around, or that we throw that term around often. Um, I sent an email to the national regulator asking him about the use of gas, and when all else fails, and I think I patched through about 5 or 6 extracts from the standard as we did just now, and he ended up replying by saying that if there's a rational design done by a competent person to make sure that you get balance pressure and volume and all the rest of that, and they take responsibility, that would be acceptable. So I'm not 100% sure about your arrangement there. But I would have a check just to make sure. If I remember, there was actually a court case somewhere in Gauteng of a lady burning the lower face and top of her torso with water because someone opened the tap somewhere and she ended up with that boiling water from the gas geyser going onto her skin. So just have a look at what you're doing there.
All right. And then the last question I've got for the moment reads, what happens when the owner of a building insists that the plumber proceed with the work that is not compliant? For example, where the vent pipes are in the roof, but the board corporate rules don't allow exposed drainage pipes.
Okay, when we did, if you check in, I'm not sure about the months, I'm thinking it's around probably July, August somewhere, we did those TAC resolutions. There's one in there that says that you may notify your client and your developer upfront by saying that these vent pipes are non-compliant, and you've done your bit, you've notified them, you've emailed them, you've spoken about it in site meetings and all the rest of that, so that by the time this thing gets audited, your workmanship will get audited, not the actual fact that they didn't have the vents in the right places. They'll check the work, or your workmanship will get audited, and then obviously your non-compliance notice, like you would for a geyser, would then indicate that on that and that day I sent an email to the owner and the architect or the builder or whoever, just to say that we are not above board here, and we might not get this building signed off, worst case scenario, but the point is, then at least you've got yourself covered. So they can insist as much as they like. They can't force you to break the law. So if they insist on not seeing them, then you need to inform them that it does not comply, and should there be any consequences, it'll not be for your account. I'd suggest just have a look at that TAC resolution. There's a nice chat about it with some evidence that went into some buildings and what the requirements are. So just have a look at that. It'll clarify it for you even better.
All right, perfect. Well, that is all of the questions I have got for you this morning. Adrian, would you like to go ahead and end off?
Yes, thank you, guys. Thanks for popping in this morning. Hope you enjoyed it, and we'll chat again in the near future.
Right, perfect. And then just from our side, guys, thanks so much for joining us. I am going to go ahead and end the session off now. Enjoy the rest of your week, guys. Bye-bye.